Welcome friends to my YouTube channel. Now in today's lecture I shall going to discuss an important issue, that is the surface tension and vapor pressure. Okay, surface tension and vapor pressure, that is the pressure exerted by the liquid vapor. Okay, so for this purpose we take the example of concave meniscus, that is when a liquid is dipped in a capillary tube that wets the walls of the tube, we know that concave meniscus is formed. Okay, a concave meniscus is formed like this. Okay, and okay, so concave meniscus is formed. So this is the liquid and this is its saturated vapor. Okay, we denote it by dot dot. This is the saturated vapor. Okay, suppose this is the point P and this is the point Q. Now obviously here the liquid is in equilibrium with its saturated vapor, and the entire system is kept inside a evacuated chamber. Okay, so that there is no effect of atmosphere, or we can say the effect of atmosphere can be neglected. Okay, so the entire system is kept in a evacuated chamber so that atmospheric effect is neglected. Fine. Now here we have to assume few things, that suppose the density of liquid is rho and that of vapor is sigma. Okay, and we imagine that P is the saturation vapor pressure over the flat surface. This, okay, saturation vapor pressure over the flat surface. Okay, P is the saturation vapor pressure over the flat surface. Okay, these things we have to imagine. Now as I tell earlier that just we draw it again. This is the concave meniscus. Okay, and this is the vapor and this is the liquid. Okay, we take this point as P. We draw it small portion that I draw. This is the vapor and this is the liquid. Now you can say that the pressure just above the concave surface is different than the pressure below the concave surface. Obviously in upper surface there is vapor and in lower surface this is liquid. So vapor pressure just above the concave surface, and we assume that the P is the saturation vapor pressure over the flat surface, right? P is the saturation vapor pressure over the flat surface. So what will be the vapor pressure just above the concave surface? Obviously this is P minus Hg into sigma, because above there is a vapor whose density we imagine sigma. So this is the vapor pressure just above the concave surface. And what would be the vapor pressure just below the concave surface? Below the concave surface, this is simply P minus, this is liquid, that is Ag. Okay, okay, so what will be the excess pressure? This minus this term is large because sigma is small. Okay, and this term is small because rho is large. So what would be the excess pressure? The excess pressure is this, that is P minus Ag sigma minus P minus Ag rho, that is simply Ag into rho minus sigma. So this is the excess pressure, okay, Ag into rho minus sigma. And again we know from our previous discussion that excess pressure inside a concave surface is what? Concave spherical surface, this is 2T by R, okay, not spherical film, that is for spherical surface, okay. For spherical surface, what we get? For spherical drop, we see the excess pressure is what? Excess pressure is 2S by R. S is the surface tension and R is the radius of the drop. So this must be equal to this, okay. So Ag into rho minus sigma, that we can make equal to 2S by R. So from which we can easily write Ag is equals to 2S by R into rho minus sigma, okay. Ag this equals to 2S by R into rho minus sigma. Now if we substitute the value in previous equation, that is vapor pressure, so what? Vapor pressure above the concave surface is what? We get P minus Ag sigma. So now we have to substitute the value of Ag, that is P minus 2S sigma by R into rho minus sigma. So we see that the saturation vapor pressure over the concave surface is always less than the vapor pressure at the flat surface by this amount, okay. This is the flat surface, here we take pressure P, so this pressure is always less than the pressure on the flat surface by this amount, okay. Now in today's lecture I shall take the example of those liquids that weights the walls of the tube, right. Now in my next lecture I shall going to discuss the second case, that is those liquids that does not weights the walls of the tube, that is for convex meniscus, okay. So dear guys, if you don't subscribe my channel, then kindly subscribe it to get latest videos in physics, okay. So thank you.